This screencast will walk you through the process of setting up the m0n0wall traffic shaper feature to accommodate a handful of voice over IP devices on your network. The beginning of this process starts with doing a little bit of homework. Even before you get to the configuration of the m0n0wall router, you're going to need to know what the worst case available bandwidth is to your ISP. In this case, I've gone out and I've done a day's worth of testing. That is, I've tested at various times of the day with speed tests to various different server points around the country. And what I've determined is that while Comcast says this cable modem connection is supposed to be 8 megabits down and 768 kilobits up, I'm actually getting a worst case measured performance of 7537K down and 721K up. This is the basis of where we start configuring the traffic shaper in m0n0wall, because you need to know the actual available bandwidth, not what they've sold you. It's a very good idea to start by going into diagnostics and making a backup of your router's configuration. m0n0wall makes this very easy by letting you download one little XML file from which you can restore the router's entire configuration if you have to. After that, we'll go to the traffic shaper and look at what's made available to us. There are 4 parts to the traffic shaper, 3 really engaged in it, and 1 is a little convenience tool. Rules, pipes, queues, and what we call the Magic Shaper Wizard. Now, it's in this Magic Shaper Wizard where we can get started. And as I said before, I've got measurements for my actual achievable speed. I've got 7537K down and 721K outbound. Now, what the Magic Shaper really is a macro that will go through and create all the necessary queues, pipes, and rules to give us a good starting point. It saves us having to set up an awful lot of things by hand. So once that's done, we tap Apply Changes, and now the router has taken up those settings. And now you can see there's a series of queues. Queues are buffers into which traffic is held while it awaits transfer into a pipe. Pipes are the actual mechanism that conveys the data to and from the ISP. And rules are a set of constructs for dividing the traffic on the basis of application. You can see there's a variety of different things, including rules for DNS, rules for ICMP, which would be responses to pings, and there's rules for inbound and outbound traffic on the WAN connection. So let's examine this idea of queues for a moment. Queues are a set of weighted buffers. So a rule directs a bit of traffic into a particular queue, and then you can see by their various assigned weights that they will get greater or lesser priority as the traffic is passed out to the ISP or brought in. Buffers like this are by their nature a problem for VoIP because all they do is add latency. So sometimes it's necessary or desirable to pass traffic through the rule directly into the pipe that gives it the connection to the ISP and not dump it into a queue first. So here we've got our 2 pipes. Based on the numbers that we had put in before, it's given us 7160 kilobits down and 649 kilobits up. So 1 pipe in each direction. That would normally be fine, but since we're talking about VoIP traffic, I'd like to establish a couple of pipes that are dedicated solely to the VoIP traffic and hard set up the allowable bandwidth for those. So let's add a new one here. We'll make this pipe be for our upload speed. What I'd like to do is I'd like to set aside 256K of available bandwidth, which would accommodate 3 simultaneous G711 standard toll quality calls. They consume about 80K per with TCP overhead and whatnot. And all I really need to do here is set up the bandwidth allowed. I don't want to induce or incur any additional delay or make any other adjustments except to give this a label and call it dedicated VoIP outbound and save. Now, because we've gone and applied some of the bandwidths that we would have on our total upload to the dedicated VoIP column, I'll need to go in here and adjust that downward from 649 to 649 less 256, which is 393. There we go. So in concert, those two are 649 kilobytes, but we're assigning 256 kilobits worth to the VoIP traffic on the outbound side. Now on the inbound side, rather than taking the entire 7125K, I'd like to take 256 and assign that to dedicated VoIP inbound. And having done that, I need to revisit this total upload pipe and take 256 off that, which will give us 6869K, which is still a decent amount of traffic for general downloading. Having made these changes now, I tap Apply Changes. They'll be taken up by the router core. Now we can move on to establishing some rules to direct the VoIP traffic into the pipes that we've set up. So we can go to the Rules page, way down at the bottom where we can add a rule. The first thing we have to select is the target for this rule. We'd like traffic that meets this rule to be passed into pipe number 3, which is our dedicated VoIP outbound pipe. We need it to deal with the WAN interface because it'll be outbound traffic. And normally, most traffic would be TCP, but in this case, I would set it for UDP, which is going to mean that the media streams for the VoIP calls will match the rule. And now, the source on my LAN, I'm going to allow to be a range of network addresses. The way I handle things is I have the DHCP server in the router reserve network addresses for my VoIP devices at .128 and higher. So by setting this to 192.168.1.128 and then specifying the subnet range to 25, what I've done is I've said all addresses 128 and above are going to be able to match this rule. I'm not particularly concerned about what ports are involved or what destinations on the other side of the router or anything like that are involved. Although I do know that this is an outbound rule, so I only need to match outbound traffic. As we get lower down here in the settings on the menu, this is where we can establish some type of service or TOS tags as well. We want low delay and maximum throughput. And then we will give this rule a dedicated VoIP a name and save it. Now that rule is going to show up way at the bottom, and this being something that we think is perhaps a high priority thing, you may want to go about the process of moving it up stack. Unfortunately, there's no easy way to do that. I'll show you going about it a couple of different times. You just use little arrows here to move it up. But you get the point. So the next thing we'll need is a rule to match our inbound VoIP traffic. And so we want to, again, go down to the bottom and add another rule. In this particular case, the rule is going to match dedicated VoIP inbound, which would be pipe number 4. On the WAN interface, and again dealing with UDP. In practice, you could probably say any protocol here because we really don't care, but by saying UDP, it specifies the media streams explicitly. The source in this case we don't particularly care about because the source is going to be on the other side of the network, or the other side of the WAN. What we do care about is the destination, and here again we'll specify network 192.168.1.128. Subnet 25 on inbound traffic, and again, low delay and maximum throughput on the TOS. And this becomes dedicated VoIP inbound. Save that setting. We've got this new rule. So now we have two new rules, one governing VoIP inbound. We should probably move it up quite a bit. I like to put these things at the top, but we'll just leave them where they are for now. Once you've applied the changes, then the traffic shaper should uptake the new rules, new pipes, etc. And you should be good to go.